do from the first one? You want to pick a question that, you know, is very confusing and you need help on it. If the answer is none, that's fine. Okay. Is it just that you need something cleared up? Guys, what do you need me to do from the first homework?
No.
Nothing? Okay. What about the second one, power and efficiency?
What's for doing now?
I'm just trying.
Does anybody have any question?
Yeah, like what do you need me to do from the homework?
Like, do you have any problem that you don't understand?
No? You could do all the questions?
I know I haven't finished it.
Ah, nice. In which lesson? Okay, let's do number 3 in power and efficiency. Does that involve an angle, Bello? Like what's the particular?
Yeah.
There's an angle in it.
There are like 1, 2, 3, 4, 5, 6 questions.
Okay, so fine, that's a good one. We'll do number 3 and then we'll start the next lesson, yes? Bello, do you mind reading the question to me since I don't have it open? What's it say?
It says a large loaded passenger jet aircraft has
Okay.
a total mass of 400 tons.
400 tons. So that's 400,000 kilograms, okay?
And is waiting to rest on the runway with the wind brakes applied.
Okay.
All the engines are running and provide a total forward force of 600 kilonewtons.
Okay.
It says calculate the initial acceleration of the
Alright, so the first part A, that's easy peasy, isn't it? What formula do we use? F equals ma, correct? A equals F over m. So what's that, 1.5? Is it? 1.5 meters per second squared? Yeah. Come on guys, are we all awake? Is this right? Yeah. Right, B, Bello, go on.
Give a reason why the initial rate of acceleration cannot be maintained.
Good, okay. So the acceleration is 1.5 at the beginning, but it won't continue to be 1.5. Why not? Yeah, but why? Now we've done this before. Yeah, so what's the vocabulary here? We have a special word for it.
The drag.
There you go. The drag force will increase. And this will cause reduced acceleration. Right? Okay. Bello, part C when you're ready.
Shortly after taking off, the aircraft climbs on a straight line path of slope 10 degrees
Okay.
to the horizontal.
So it's going up in the air like this at 10 degrees.
At a constant speed of 75 meters per second as shown in
Sorry,
the
what?
diagram.
75
Yeah,
meters per second. Okay.
as shown in the diagram.
Okay, so it's taken off. Off it
Calculate
goes.
the height
Yeah.
gained per second.
Okay, so in 1 second, how far has it travelled? 75. And the height will be 75 sine 10. And what's that, please? What is it?
13 of them.
13. Oh, I don't want to write it there. Sorry. 13 meters. Okay. D. What's next?
CI.
Oh, okay. Whatever. I don't care. D. Yeah. Over time.
Show the
No, D. Whatever. Yeah.
show the gain of gravitational potential energy per second is approximately 51.
Okay, so the potential energy per second is mgh. What did I say the m was? 300,000? What was it? 400,000. 9.81. 13. And what is that?
It should be equal to 51 MW.
That's 51 megawatts.
Yeah.
Now, why is it megawatts and not megajoules?
It's per second.
Yeah, because in the question they wanted the MGH per second. Okay, next. E.
Given that the engines are working at a total power of 54.5 megawatts, calculate the total frictional force acting on the aircraft.
Is that the last part?
Yeah.
Yeah. So, I scroll down a little bit. Here's our aircraft. The engine is helping it take off. And then we have some friction acting down. And now, hang on, how do I want to draw this? So you have the weight and you have the drag. So I'll just draw them together, and there's some, I don't know how to draw it, there's some friction force this way. Okay? And then the engine must balance the force the other way. Now, I know they must be equal. What about the question makes me know that they're equal?
Calculate the total
Speed is
frictional force.
constant.
Yeah, but how do I know it's constant? It's because the speed is constant. And we know the speed. The speed we said was 75 meters per second. Okay. So look, what did they want? The force? Was it? Yeah, so look, the force here will be the same as the force here. Okay? And we can use a little formula here. Oh, this force is from the engine, isn't it?
Yes.
Yeah. So, remember we said power is work over time. In this case, what type of work is being done? It's potential energy, isn't it? MGH over T, isn't it? Now, we know, I forgot, what am I looking for? Oh, the force. Power equals work over time. Work equals force times distance over time. Now, because it's moving at a constant speed, the distance over time is the velocity. Okay, sorry, it took me a second to process that. That was the trick we did last time. Remember that question I had of the car going up the hill? Yeah. We know this. We know this. Okay, great. So we want to get the F. F will equal P over V. So 54.5 mega over 75. So what's that? Like 0.6 something mega? What's 54.5 over 75, please?
0.7.
Say again?
0.726666.
Okay, so that would be 727.
Yeah.
If I want to keep it in units of mega, that would be mega newtons. Now that last part is hard. I know it's hard because last time when we did it, it was hard, and today it's still hard. This seems to be the trick. This seems to be the trick. Now, there are other ways to get the answer. Yeah. Yeah, there are other ways to get the answer, but I like this way because I don't know. I just like it. I think other ways might be a little harder. Yeah. Okay, fine. The only thing I'm not 100% sure on is when they say frictional force, I feel like they mean both the air friction and the weight that's pulling it back. But it's not 100% clear to me that they mean both. If they didn't mean both, what would I have to do to my answer? My answer would be too big. Because this answer includes what forces? gravity and the weight and the air friction, the drag. I would have to take out the weight part from this total. But I really doubt that that's what they want me to do. Because it's a section A question, it's already very long, and this is the last part of it, and it's probably only like 1 or 2 marks. Bello, is the solution uploaded yet for that or not? Probably not. You probably have to go into the exam to look at the solution, yeah. Did anyone look at the answer? Is this right? Would somebody please check, and then we'll go on to the next lesson.
So how do you check?
Well, under the question, I list where it came from. So you can just go into the exams and open up the solutions. You see where it says source?
Yeah.
Yeah.
The question for second. Yeah.
Does anyone have the marking scheme open yet?
Looking at.
You're looking at it?
Oh, really?
Have you got it?
Yeah, not the one.
You got it? Come on, guys. What's taking so long to open it?
The force is
It's not the answer.
no, the power is not same.
Huh? But you just told me the power was 54.
The power is here was like 3.5.
Yes, 3.5.
They put the wrong power in.
Main power.
Bello, you said the question said the power was 54, yeah?
Yeah.
Yeah, that's what the question says.
And the marking scheme has a different power.
No,
It's the same thing. 3.5 instead of 54.
And you're saying ball is an aircraft, not a ball.
Huh?
I had ball. Someone was saying
Yeah,
ball.
it wasn't the right question.
We're talking about an aircraft, not a ball.
Come on, guys. Just open up the right one,
Yeah,
please.
Yeah, like the answer says the power is different.
It is the right question.
Yeah.
Okay, so what did they do? What did they do?
They used that 54.5 minus 51.0. And
So they get.
so it's equal to 3.5.
They said minus 50.
54.5 minus.
Minus
Ah.
51.
Yes.
Ah, okay. So then we have the answer. They do want only the drag.
Yeah.
My answer is too big because it includes the weight.
Yes.
Yeah. Okay, well, any ideas how I can fix it? It's not a big deal to fix it. I can easily fix it. Look up.
The power minus.
Yeah, well, it's too late for me to do the power minus because I've already gone this way. But what I can do is this. Can you all look up, please?
You can use that.
Yeah, this here is 0.727. Okay, and then this back here is 0.727. What I'll do is I'll take the weight and I need to resolve it. Yeah? So this here at the back will be drag plus the weight, which is, what do we say, mg, and this angle here, 10, sine 10. So I hope if I just take this answer and do a minus mg sine 10, I get the right answer now. Otherwise I have to start again from the beginning, which I don't want to do. My answer's too big because I included the weight. They just want the drag. Okay, that was a good one to do, Bello, because it was tricky towards the end. Did you type that in, please? What was it, 400,000? Yeah. And remember, this is 10 to the 6. Could you type it in, please? I'm waiting for a number. Come on, guys, faster, faster.
One.
Do the difference.
All right, fine. I'll start it again.
No, you just start the.
Yeah, just that part. Yeah. No, I'm not going to do the whole thing again. It's just the last part. Right, okay. Let's start this again. Right, so just to recap, guys, please, killing me. Right, there's a couple of things we worked out. We need to write them all down. We worked out the power due to the gain in gravitational energy. What was that number from earlier? It was 51 point, just 51 megawatts.
Yes.
Okay, the power of the engine was what? 54.5 megawatts. Now here's the important part, okay? Suppose I told you to go up a hill, I need the engine to have 10 megawatts. And then when the engine does go up the hill, it actually needs 12 megawatts. Why did it need the extra 2? Well, because of friction that we didn't consider earlier. Okay, when we calculated this 51 megawatts, we weren't talking about friction yet. When did friction appear? In the last part. And now all of a sudden the engine isn't 51, it's now 54.5. So the extra power is, what's that? 54.5 minus 51, 3.5 megawatts. That is the extra power only because there's this new friction drag force. Okay? If there was no friction, we wouldn't need this extra little bit. Okay? Now, I can still use my formula, I hope.
Yeah.
Do you remember the one that says power equals, what do we end up saying? F times V. So hopefully, if I divide this by 75, I get the answer in the marking scheme. I do. Okay. Okay. The correct answer now. Okay. Right, now guys, look. We'll start the next lesson. I'm happy with the homework. This is exactly what I picture homework should look like. You try the questions, and then the one weird, hard question that you can't do, I do on the board. Okay? This is how I imagine it should be going. Yes? Okay? Right?
Yes.
Right? So this is a good one. What year was that one from, did it say in the source?
2009.
Right, that's good for you, because it means whoever wrote that exam is long gone.
Yes.
It's a different person writing the exam now, so you're not likely to get one like this, because there's a different writer now. They change the writer every couple of years. Okay? Yeah.
So this is
Yeah.
mega, is a mega newton, right?
It become meganewtons then. All right.